Hello students, welcome to my channel Mastering Physics and Math. In this paper, Cambridge International AS&A level Physics, this is the number of the material 9702/11. Paper 1, multiple choice, May-June 2019. Question 16. An empty glass beaker has a mass of 103 grams. When filled with water, it has a total mass of 361 grams. When filled with cooking oil, it has a total mass of 351 grams. The density of water is 1.00 gram per centimeter cube. What is the density of the cooking oil? Now the mass of water, M water, equals the difference between this figure and the mass of the beaker, minus 103 equals 361 minus 103 equals 258. The mass of oil equals 351 minus 103 equals 248 grams. Now to calculate the volume of the beaker, we calculate from the mass of the water and the volume of the water and the density of water. Now since the raw water equals mass of water over the volume, so the volume equals the mass of water over density of water. (258 gram over 1.00 gram per centimeter cubed. Now this gram cancel out with the gram, and this unit goes up centimeter cubed. So this volume equals now density of oil, raw oil, equals the mass of oil over the volume. Mass of oil is 248 grams and the volume is 258. (248 over 258. Now, this answer must be rounded to 3 significant figures. So, the answer is 0.961. .961 gram per centimeter cubed. A is the qualified answer. Question 70. A rope is attached to a sled and a boy uses the rope to pull the sled along a horizontal surface with a constant velocity. The tension in the rope is 100 Newton and the rope is held at 30 degrees to the horizontal. How much work does the boy do on the sled when he pulls it a distance of 5.0 meters along the surface? Work is the scalar product of F, the force, and the distance. And this is equal to the magnitude of the force times the magnitude of the distance times cosine the angle 30. The force is 100 Newton and the distance is 5.0 and cosine 30 is root 3 over 2. Repeating the calculation, 100 divided by 2 equals 50. This 50 times 5 root 3. So the answer is 433, and to two significant figures is 430. So the answer here is 430 to two significant figures. 18. The kinetic energy EK of an object of mass m moving at speed v is given by the equation EK equals half mv squared. Which equation is not used in the derivation of this equation? The kinetic energy equals the work done on the object to move it from the rest to its velocity v. So the work equals the force times the distance. So this equation is used. So this equation, we use it. Now, F equals ma according to Newton's second law. MAS. So this is also used. These two formulas are used. Now AS, to find the value of AS, we use this equation. It gives us a relation between the initial velocity and the final velocity. So AS here equals, of course, U squared is considered here to be 0, equals V squared over 2. So substituting here AS, so we get that the kinetic energy EK equals M times V squared over 2, which is half mv squared. So this is the only equation that is not used in this derivation. A grasshopper of mass 0.12 gram jumps vertically. It uses its back legs over a time of 0.020 seconds to jump, leaving the ground with a velocity of 3.0 meter per second. What is the average power developed by the legs of the grasshopper? Power equals the work over the time. Work done over the time. And the work equals delta kinetic energy, delta E kinetic over the time. Delta E kinetic equals the final kinetic energy, half mv squared minus 0. The initial kinetic energy is 0 over T. So this is equal half. The mass is 0.12, converting to kilogram, multiplied by the square of the velocity, 9, and dividing by the time. The time is 0.020 seconds. This is joule here. Now half is 0.5 times the mass is 0.12 times 10 to negative 3 times 10 to negative 3 times 9 divided by 0.020. The answer is 0.027. Watt, because joule over second is watt. So this is the qualified answer. A spring of original length 100 millimeter is compressed by a force The graph shows the variation of the compressing force F with the length L of the spring. What is the energy stored in the spring when the length is 70 millimeter? We can solve this question by two methods. The first method is that the energy stored equals this area, the area under the line. Because the spring is compressed to this value, so this triangle, the area of this triangle it is a potential energy, of course. The potential energy equals the area equals the area of the triangle equals the half the base times the height. The height is 6. Half times the delta x is 30. 100 minus 70, 30 millimeter converting to meter times 6. Now this is 3 and this is 1, so 30 times 3 is 90 times 10 to negative 3, which is this answer, joule. This is the first method. Now we can solve it by another method, method 2. The method here is to calculate the spring constant K. Spring constant K equals the force over the compression distance equals F over delta L equals 12. Here it compressed 60 millimeter, 100 minus 40 Newton over 60 times 10 to negative 3 millimeter over 60 times 10 to power minus 3. Now repeating the calculation, 12 divided by, using the brackets, is better, 60 millimeter converting to meter times 10 to power negative 3, close the bracket, 200. K for this spring, what is called the spring constant or Hooke's constant. K equals 200 Newton per meter. Now delta X equal 70 millimeter minus 100 millimeter equals minus 30 millimeter. Now the energy stored in the spring, this means that the potential energy stored is a potential energy. So the E potential equals half K x squared equals half times 100 times 30 converting to meter squared. Using the calculator, half times 200 is 100 times times 10 to the power negative 3 squared equals 0.09. Joule, so we get the same answer. Enough for this video. Thank you for following me, and bye bye.